The overall goal of this procedure is to fabricate mechanically tunable and bioactive metal scaffolds for biomedical applications.
This method can help answer key questions in the orthopedic implant field, such as the feasibility of a mechanically tunable metal scaffold that is capable of delivering drugs. This densification method is simple because it requires only one control parameter, achieves both mechanical enhancement and sustainable drug release, and is capable to the fabrication of functionally graded porous scaffolds.
First, mix the appropriate amounts of titanium powder, camphene, and KD4 for porous titanium scaffolds with 4 initial porosities in 500 milliliter polyethylene bottles. Rotate the bottles in a ball mill oven at a speed of 30 RPM at 55 degrees Celsius for 30 minutes. Pour the slurries from the polyethylene bottles into cylindrical aluminum molds with a diameter and height of 60 millimeters. After sealing each aluminum mold with an aluminum cover slip, rotate the molds in a ball mill oven at a speed of 30 RPM at 55 degrees Celsius for 10 minutes. Subsequently, decrease the temperature of the ball mill oven to 44 degrees Celsius and continuously rotate the molds at a speed of 30 RPM at 44 degrees Celsius for 12 hours. After cooling the molds by rotation at room temperature for 1 hour,